So, what if the entire universe, and I mean everything from the smallest quantum flutter to the slow cosmic dance of galaxies, could be explained by just one single elegant process? It sounds like science fiction, right? Well, let's dive into this because a seriously bold new paper is claiming to have found exactly that. All right, so here's our roadmap. To really get what this new idea is all about, we first got to understand the huge problem that has split physics for 100 years. Then we'll get into this wild new transformation principle that claims to be the bridge. From there, we'll see how it brings everything together at the tiniest scales imaginable, how it helps us solve crazy cosmic puzzles like black holes, and finally, and this is the important part, we'll see how we could actually go out and test if any of this is real. You know, for almost a century now, physics has kind of had a split personality. It's ruled by two incredible theories that describe our universe with stunning accuracy. The only problem is they completely contradict each other. And this isn't some small disagreement. This is a fundamental conflict that has kept physicists awake at night for generations, hunting for a single, unified truth.
Okay, so on one side, you've got Einstein's masterpiece, general relativity. This is the physics of the big stuff. Planets, stars, entire galaxies, all gliding through the smooth, continuous fabric of space-time. But on the other side, you've got quantum mechanics, the beautifully weird physics of the super, super small. In that world, everything is pixelated, it's based on probability, and it's fundamentally uncertain. Here's the problem. They speak totally different languages. If you try to use general relativity to describe a quantum particle or quantum mechanics to describe a black hole, the math just, well, it completely falls apart. So how in the world do you bridge a gap that big? Well, the authors behind this new framework are proposing something really out there. It's not a new particle we have to find. It's not some hidden dimension. It's a brand new fundamental principle, almost like finding a Rosetta Stone for the entire cosmos. They call it the Delta Infinity Omicron Framework. Now, this isn't a new force or some new stuff to add to the universe. They call it a meta-structural principle. Okay, that sounds complicated, but here's what it really means. The universe isn't fundamentally made of things, it's made of a process, a constant ongoing transformation that connects the quantum world to the big classical world that we all see and live in. So here's the core idea, the big analogy. Picture the quantum world, all discrete and jumpy, as a simple triangle. And picture the smooth, continuous world of gravity as a perfect circle. Now, how do you get from a triangle to a circle? Well, this theory says it happens through an infinite number of tiny, tiny steps, a mediating process that slowly morphs that triangle, adding more and more sides until it becomes the circle. And that transformation, that process, is what this theory says reality is. So let's just quickly break down those symbols. The delta, our triangle, that's the infinitesimal world of quantum mechanics. The Omicron, our circle, that's the big, finite universe of general relativity. And that infinity symbol, the one right in the middle, that's the real key here. It's the mediator, the engine of transformation that connects them, and it all happens at the most fundamental level you can possibly imagine, the Planck scale.
So, where does this grand transformation actually take place? Well, the key to unifying everything isn't found out in space or even inside a star. It's at the smallest, most ridiculously extreme scale you can think of, a place where the rules of both theories are finally forced to come face to face. Welcome to the Planck scale. You can think of this as the absolute floor of reality, the point where our ideas of length and energy hit their quantum limits. Down here, things get really weird. The fuzzy uncertainty of a quantum particle can become so extreme that its own gravity can cause it to collapse into a teeny tiny black hole. This is the arena. This is where quantum mechanics and gravity have their ultimate showdown. And this brings us to the paper's central and honestly just stunning claim. It turns out, if you use the math of quantum mechanics to figure out the mass of a particle at its absolute limit of uncertainty, you get a very specific number. And then, if you use the totally separate math of general relativity to calculate the mass needed to create a black hole at that exact same tiny scale, you get the very same number. They perfectly match. At the Planck scale, the two great theories of physics don't just meet, they merge into one. Okay, so the math lines up beautifully. That's cool. But what does this new framework actually do for us? Well, its real power, its real test, is in how it just elegantly solves some of the biggest and most frustrating puzzles in all of physics. Let's start with maybe the most famous question in all of cosmology, one that has driven physicists crazy for decades. What in the world is going on at that infinitely dense point right at the heart of a black hole?
For the longest time, the answer was just a singularity. Basically, a point where our physics completely breaks down, goes to infinity, and all information that falls in is just gone forever. But in this new view, there is no infinity. There is no singularity. The center is a quantum core with a maximum possible curvature. Physics doesn't break, and this is a huge deal for quantum mechanics, information isn't lost. It's preserved. The paper uses this absolutely fantastic analogy. It calls it a quantum trampoline. Think about it. As gravity tries to crush matter down into an infinitely small point, the very fabric of space-time itself starts to push back. It gets more and more rigid, resisting the crush and preventing a singularity from ever actually forming. So instead of a cosmic dead end where everything breaks, you get a bounce.
Now look, a powerful idea is one thing, but a real scientific theory is another. So the ultimate test for this framework is, does it make real concrete predictions? Are there things we can actually go out and look for that would prove it right or prove it wrong?
And it does. The predictions are pretty profound. It suggests that at incredibly high energies, the famous uncertainty principle should actually change its behavior. It implies space-time itself is a kind of quantum foam that could ever so slightly affect the light we see from distant objects. It even rewrites the story of the Big Bang, getting rid of the initial singularity and replacing it with a smooth transition from whatever came before.
And right here, this is the proof in the pudding. You're looking at Heisenberg's uncertainty principle, but with extra bits tacked on at the end, predicted by this framework. Now, in our everyday world, these new terms are so tiny, they're basically zero. But if you get to extreme energies, like in the first moments of the universe or right at the edge of a black hole, they would suddenly become big enough to measure. And if we detected that deviation, that wouldn't just be a discovery. That would be the smoking gun, the first direct signal from the unified world of quantum gravity.
So, we've seen how this idea bridges the gap between the two biggest theories in physics, how it solves ancient paradoxes, and how it even makes testable predictions. But can you really wrap all of that up into a single final formula?
Well, there it is, the proposed equation for the entire universe. And I know it looks a little intimidating, but the idea behind it is just beautiful. On the left side, you have the total state of the universe, the whole shebang. And on the right, you have the state of the quantum world and the state of the gravitational world. And connecting them all, right in the middle, is that letter T, the single transformation process that turns one into the other. It means everything, from a single particle to an entire galaxy, is all part of one single, unified, interconnected system.
So let's just step back for a second. Why does this matter? Well, because if this framework or something like it holds up, it finally achieves the grand dream of physics. It unifies the world of the small and the world of the large. It wipes away paradoxes that have haunted us for decades. And it gives us one single, consistent story that describes our reality from the tiniest possible speck all the way out to the edge of the cosmos. Which really leaves us with one last huge question to think about. Maybe the most fundamental thing about our universe isn't matter, or energy, or even space-time. Maybe, at its deepest level, reality is simply a story of transformation.